Now we can talk about homework 8, problem 10. The problem is show that if the normal process is white and stationary, then it is strict and stationary. We said the normal process is xt, and we should prove if this process is a WSS process, it should be a SSS process. Now we know that if xt is a white and stationary process, the expect of xt should be a constant number, and the autocorrelation function should only has relationship with tau, with the difference of time. We know that xt is normal process, and for normal distribution, we know it's for normal distribution, we should know its n-dimensional density distribution function. That equals now this formula is the n-dimensional density distribution function for the normal distribution, and the k is covariance matrix. It's the covariance matrix for those normal distributions, and M is the expect. So we found that for the normal process, it's only related with K and M. So if we want to prove this formula, this formula is the definition of strict stationary. So if we want to prove this formula, we only need to find that K and M they are not change. They don't change. K is the covariance matrix for x to t like this, and it's for now we only need to find this two. We only need to prove these two equations, and we know that the xt is a normal process, so its expect is a constant number. It's very easy to find. Its expect didn't change because it's a constant number. It's not related to t. It's not related to the time. Now we should to prove k doesn't change. We begin the provement with an element in the matrix. Like this. It equals xti minus mx times xtk multiply xm. And it equals e xti times xtk minus mx to the power 2. It equals the autocorrelation function t1 tk minus the expect to the power 2. We know that the xt is a WSS process, so that's only related to the difference of time. So it equals r t k minus ti minus mx to the power 2. And now we can calculate the second covariance. That is the same. It equals x ti plus tau minus mx. We know that the expect didn't change. Time x tk plus tau minus mx. So it equals tk plus tau minus ti plus tau. So it equals tk minus ti minus mx to the power 2. We proved that mx didn't change, and this part equals this part. So the element in the matrix didn't change, so we can say that the covariance matrix didn't change. Now we can say that if xt is a WSS process, it must be a SSS process.